All right, I think we can get started. Hello, everyone. Let me just advance slides. Perfect. Hello, everyone. Welcome to the Calgary Virtual Meetup Group. My name is Jimmy Atia. I'm a Senior Strategic Advisor with MuleSoft Customer Success Strategy and Architecture team. Today, we will be discussing an interesting topic regarding RTF, which is RTF security. For those who attended our previous meetup and within the Calgary Meetup Group, we discussed the RTF deployment model and how it is different from the other supported deployment model from MuleSoft. Today, we will dig a little bit deeper into how to secure your MuleSoft APIs that are hosted on RTF. Today, we have a great team driving the discussion. But before I start, let me briefly in today's session, we may talk about future-looking products and services which are subject to risk and uncertainty. We would like to remind you all that you should make your purchasing decision and investment based on products that are currently commercially available. As I mentioned, we have great speakers for today. Fun fact, those guys are joining from 3 different countries. I will briefly introduce them, but they will get the chance to properly introduce themselves as they get to talk along the discussion. So we have Mandy Wong. She's an API integration specialist from Suncor. She's also a co-leader in the Calgary Meetup group with me. We have Manesh, integration architect from Millennium. We have Brian, MuleSoft practice manager from Big Compass, Connor, senior consultant, Big Compass, and myself from MuleSoft. This is the meetup agenda for today. We're going to start by some meetup logistics right after this slide. And then we will hear from Mandy about a customer perspective. What are the challenges from the customer perspective when it comes to RTF deployment, especially when we discuss security. And then we will switch over to Manesh, who will be taking us through a journey in Anypoint Secret Manager. During the presentation, there will be a trivia question. I think lots of you who used to join us knows about the trivia questions. So we will be asking 3 questions along the way. And the first winner with the right answer, we will pick 3 for the 3 questions, will win a free MuleSoft training. And we will announce the winners at the very end. Then Manesh will switch over to Brian and Connor. They will talk deeply into the RTF security in terms of network security and API security. There will be the second and the third trivia questions, and there will be a demo for both Connor and Brian. And at the very end, we will be announcing the winners. Quickly, through the meetup logistics, this session is recorded, and a copy will be published to our meetup channel, YouTube channel. It's called Alberta MuleSoft Meetups, and also I will publish a link to the video in the meetup page on MuleSoft Meetups. Attendees will be placed in mute. So please, if you have any questions, and we encourage you to ask lots of questions, please put them in the chat section, and myself and Mandy will be collecting all those questions and filter them and then ask them as we go to our speakers. As I mentioned, there will be three trivia questions, so please pay attention. The answers should be, if you're paying attention to the session, you should be able to answer them all correctly. And as I said, the winners will be announced at the very end. There will be some, like the way we receive the answers, like a specific way. So pay attention to Mandy when it comes to the trivia questions. She will give you instructions on how to put the answers. So basically, we need to listen to the questions and all the answers, and then I will hit like go now in the chat section, and then you go ahead. The prize is like a voucher for free MuleSoft course. With that's my part. I'm gonna switch over to Mandy to provide the customer perspective. Mandy, please take it away.
Thank you, Jimmy. And as Jimmy introduced me earlier, I am an API and integration specialist with Suncor Energy here in Calgary, Alberta, Canada. I've been working with MuleSoft for 3 years now, and I am a big believer in accelerating digital transformation through the use of APIs. And recently, our team is migrating APIs from the on-prem environment to the Runtime Fabric environment. And there have been a lot of questions that have come up regarding how to best secure our APIs. So, first one, how do we secure secrets? Is there something already available in MuleSoft that we can leverage to secure our precious data assets? The second question is, what is the best way to go about encryption of properties at rest? Is there a best practice, or what other things do we need to consider when we think of encrypting properties? When does tokenization come in, and how is that different from encryption? Are there benefits of doing one over the other? Are there cons of doing one over the other? What other aspects of security do we have to consider when we deploy our APIs to the Runtime Fabric environment? There are probably a plethora of things we need to consider, and we really want to nail down the main ones. And are there risks involved if we don't employ certain techniques to secure our APIs, and how big are these risks? And lastly, is there the one thing we must do in order to achieve security when we deploy our APIs in the Runtime Fabric environment? And today's presentations and demos, I hope, will answer all these questions.
Perfect. Thank you, Mandy. I think with that, we can switch over to Manish. Manish, I'll stop sharing and you please go ahead.
Thanks, Jimmy. Let me switch on my camera just to. I'm not sure. Can you see my screen? Guys, can someone confirm?
We can see the meetup screen, not the presentation screen. Yeah, this is the one.
Yeah, so
Yes.
basically, I'll start quick introduction about me. Thanks, Jimmy and Mandy, for opportunity. So I'm Manish Yadav, working as an integration architect with Millennium, Poland. I'm one of the MuleSoft ambassador since 2017-18, and I have been working in MuleSoft since the starting of my career in 2015. I'm also part of co-organizing meetup in different city like Pune in India, Mumbai in India, and Kuala Lumpur in Malaysia. So I have been part of different uh, uh, group as well as different meetup and other stuff in with respect to MuleSoft. I'm also one of the MuleSoft forum moderator who is managing help.mulesoft.com. If you guys have heard this, always people are trying to search the question and answer on help.mulesoft.com. So this is something that I'm moderating whole forum, I would say. So that's a quick introduction about me. So today we'll start with the uh, secret manager. This is something that nowadays in the community, a lot of people are asking a lot of questions in the forum, and basically uh, I wanted to give you the deeper understanding what exactly the secret manager is, and this is something I'll walk through the basic understanding of the secret manager and the demo. Yes, overview of secret manager. I'll not talk much about the uh, theoretical part, but anyway, I have to explain what exactly the secret manager is. Slide is self-explanatory, but still I'll go through the uh, basic fundamental of secret manager. Secret manager is nothing but a platform service provided by MuleSoft, which internally use a secure vault technology to store and control the private key. Not only the private key, you can store the password, you can store the certificate, you can store, create the key store, trust store with the certificate, and you can store these all uh, data as secret in the secret manager. Secret manager has also the REST API they provide to upload all the secret. If you are not big fan of UI, you can use the secret manager REST API to upload the secret. So if you see, So secret manager has a different type of secret. So when I say secret, it's nothing but a, you know, the the data you want to store from the security perspective. So key store, trust store, certificate. These, we'll talk more about this deep dive, how you can configure, how you can upload key store, trust store on the platform or on the secret manager. TLS context, shared secret. You can see the shared secret, username, password, symmetric key, and S3 credential. So just for your information, this is not in right now. MuleSoft haven't released this, but this is just for fancy UI. You can see in the secret, share secret. It's not like in real you can use share secret part. So basically, we'll talk more about the key store, trust store, TLS context, and how we can, you know, uh, enable HTTPS proxy with 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 the help of secret manager. So this is something that I would like people to understand. If you understand this one, then it will be quite easy for me to explain other slide. So if you see, right, if you see this, this is nothing but our Anypoint secret manager, somewhere residing on the cloud, uh, in the control plane. And you treat this as yourself like user. So user is requesting certificate from the certification authority, or password from the database admin, or S3 credential from AWS admin. So this is something, the first step you guys would like to do. Like, you must have a certificate, password, or whatever secret you want to store. It's not like mandatory to have a certificate only. You can go for S3 credential, and you can go for other things. So this is something that the first step to get the information which you want to store on the secret manager. This is a step one. So once you get the certificate and information, then you have to upload, you have to log into the secret manager. I'll show you this in the demo, but so just bear with me, just understand as a theoretical part. This is something that I have to explain. So once first part is over, you have to log into the secret manager like Anypoint platform. Go to the secret manager, click on whatever thing you want to store. So once you store something, MuleSoft internally encrypt the data. So whatever you are storing, like JKS or password or S3, MuleSoft internally encrypt the whole data. So MuleSoft internally use encryption, KMS encryption, that is uh, uh, provided by the AWS. They generally use KMS encryption to store the data. So even if you are storing the password, they generally in the background they encrypt using the KMS key. So this is something, the part two. This is something you can treat as API manager proxy or Mule client. Each API manager here work as a client. So what API manager will do? API manager internally call REST call to secret manager. I'll talk more about how the REST call works. I mean, in the general, which service is responsible to provide the secret to the client or API manager. So a step three is nothing but whenever the API manager needs certificate, they internally call REST call to secret manager. Secret manager returns the certificate over the HTTPS TLS channel, so the secure channel. Once secret manager return the response with the certificate or password, whatever secret, then uh, you can call the secure API. So this is nothing but API which has a security applied on that, something like TLS context or key store, trust store. So once you get the whole information from here, then MuleSoft API manager client or whatever client will pass and call the this API. So this is nothing but in internal architecture, how it works in general. This is also one of the important topic I would like to discuss. This is something, the internal diagram. This is very well documented diagram on MuleSoft.docs.com, I would say. So if you see, right, so this is nothing but a secret group. So if you understood this, another, I think most of the slide is over now. So if you see, this is nothing but a secret group. So secret manager, in secret manager, you can have a different secret group. So secret group is one to the organization. So this is nothing but your organization, like business group, what we call in general, business group. So you have a business group, you have environment. So this secret manager is bound to the environment. So if you have environment access, you can have secret manager access as well. Okay. So this is nothing but a vault. Vault means like I am storing password, I am storing certificate, I am storing TLS context. This is nothing but a vault. So this vault, where should I store? So you can group in secret group. Whatever you want to store, you can group in a logical things, logical data, or logical folder, I would say. So secret group one is a logical folder which is responsible to store password, certificate, TLS, whatever things I have explained previously. So this is another group. Okay, so you can create multiple group in one environment, under one environment, and you can refer. So this is much more important, guys. So internally, Secret Manager uses two type of microservices. One is called Secret Manager service. This is nothing but a REST call, and another is called Secret Provider. So Secret Provider is responsible to get the actual data. Like I am storing password in this group. So this platform service is nothing but API manager. This is nothing but API manager. API manager internally call a REST call uh, through the service provider, and service provider is responsible to get the original secret. So when I say original secret, means original data like password. And there is another API called secret manager. This is nothing but publicly exposed to get the metadata of secret group, like who has created secret group, what is the creation date, what are the metadata, what is the name, something like that. So they have exposed internally two API. One is called secret manager. Secret manager is responsible to get the metadata, I would say. And service provider API is responsible to get the actual data. So if you see, this API is not publicly exposed. This API is not publicly exposed. This is something that internally MuleSoft uses, or MuleSoft platform service uses this API to get the original secret. Okay. So this is something much more important to understand how internally works. And as of now, for Secret Manager, only the API Manager platform service is supported. So yeah, as I explained, Secret Manager is publicly exposed, responsible to get the metadata. As I explained, Secret Provider is internal service to get the original data. Original data means like secret, original secret, password, certificate, and this is not publicly accessible. This is used by the platform service. So when I say platform service, API manager in our case. So this is how the secret manager and secret provider is two microservices used by the secret manager platform services. So and this is basic question, like some people would have asked this question, if why we go for the secret manager. So secret manager, so in 1-2 year back, when I was working with Mule 3.9 or something, if someone asks you to create a HTTPS proxy, you have to create a normal proxy, then download the proxy and add the certificate to enable the HTTPS. So, like as a developer, you love working with the demo. As Mandy said, people love demo, but there are a couple of person like admin who don't know what exactly the demo is. So for them, if they want to manage the certificate, if they want to manage the password, if want to manage the whole life cycle of the certificate, they can directly store in the secret manager. So for MuleSoft Ops team, it would be quite easy to 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 upload and delete the whole life cycle of the TLS context certificate, I would say. Developer also, as I mentioned, developer like to do the coding, but people like admin, they won't know how to code mostly, or like so it would be quite tough for them to do the coding, downloading the proxy, replace with the new certificate, again upload to the runtime manager to deploy the code. So this is something you can avoid using the secret manager. And these slides are self-explanatory. I'm not going to go more theoretical part, but uh, yeah, as I said, so we have a couple of permission available. Whatever the product you are using, irrespective of whether you are using API manager, runtime manager, any of the product you are using of the MuleSoft, you must have something called access or something called permission. Similarly, secret manager is also a part of platform service, and it has also different type of access, like read secret metadata. So I want to give read secret metadata access to the particular people who can only read the access. Read the metadata means who has created this secret or something like that. So we have four permission available. You can go through the access management, then go to the secret manager tab, and you can see all permission. So write secret is just like a upload. You can upload the certificate to the secret manager. Grant access to the secret might be some people. I don't want people to see my secret, or I want to give permission to other user. Then I can grant access to the people or the user. Manage secret, like deleting and other stuff, comes under the manage secret. As I said, so the secret manager uh, has a limitation. So when I say limitation, it you can use secret manager with two services only. You can use for runtime fabric, or you can use for API manager in the cloud for proxy. It's not like I am designing MuleSoft application. I want to reference TLS context. I can, it's not like you can refer directly to secret manager to enable your outbound HTTPS call in MuleSoft application. No, this is only applicable for proxy. You can't do anything with respect to the real application or batch or whatever application you have. So secret manager has two supports, one runtime fabric, another is API manager. So this is something in our scope, at least in my scope. This is something I'm going to show you the demo how actually you can enable the HTTPS proxy tunneling and uploading with secret manager. Sorry. Again, I already have mentioned, I will show you the demo in demo how it look like. As I said, secret group is nothing but logical group. So in this environment, I have created one logical group called demo secret group. So in this logical environment or logical group, you can store everything like password, TLS context, key store, trust store, certificate pin set. So this is nothing but a folder. This is nothing but a folder. Inside this folder, you can store multiple secret. That is what we call secret group. Okay, and this secret group is a environment specific. So you have access of sandbox, you will have access of secret group. Okay. Uh, yeah. So this is something. Again, see under the secret group, as I said, right? Under the secret group, you can see multiple secrets like key store, trust store, certificate you want to store. You want to store certificate pin set, shared secret. So shared secret is nothing but for password, username, password, S3 credential, and other stuff, I would say. And this TLS context. So TLS context is nothing but a combination of key store and trust store. This is something used for outbound call or outbound or inbound call. I mean for HTTP based protocol or whatever. So this is something I'll also in the demo how it look like, but these are the how secret look like. Again, uh, uh, this is another a screenshot for the same like TLS context how it would look like. Like in TLS context, you can have a combination of key store and trust store. See, so you can upload key store and trust store. I'll show you the demo, but this is something. Now, this is one demo I would like to show you guys. I mean SSL offloading. What exactly it means SSL offloading? So you have a suppose you have a web server. So when I say web server, you have a MuleSoft application running on 3 worker. You just treat this as a 3 worker or whatever. And these MuleSoft application expose on HTTP protocol. What we want we want to expose this HTTP. We want to expose this whole or proxy this protocol on HTTPS. So here is the client application. Client application hitting load balancer. This is nothing but our shared load balancer or dedicated load balancer. Okay. So client application is hitting on HTTPS to shared load balancer. Here the certificate termination will happen. It means whatever the certificate is coming via client, it will not go to the web server or not, it will not go to the web server or worker. So SSL offloading means you are offloading the SSL part here itself. You are not asking web server to encrypt and decrypt for me. No, you are giving free time to web server to respond. So if you are passing HTTPS, web server will take much time to respond to you. Do you know why? Because they have to match the cipher suit, they have to encrypt your data, decrypt and match with the exact payload and something like that. So SSL offloading means you will receive the requested HTTPS protocol and load balancer will terminate this protocol and pass normal protocol HTTP. So this is nothing but a SSL offloading. So you are giving, you're asking web server that just respond, I mean, return the response on HTTP protocol, and you must expose this whole worker or MuleSoft application on HTTP URL. Okay, SSL offloading. Similarly, we have SSL tunneling. It means client is also hitting on HTTPS. Load balancer is not terminating. It all, they are passing the you know uh, the same protocol to this. So there are a couple of things like why we go for the SSL tunneling. This is not in our scope, but basically, I'll quickly explain something. So basically in HTTPS, like might be server is have capability to encrypt data with cipher suit, some different cipher suit, but client doesn't have ability to decrypt, you know, this the same cipher suit. So client to load balancer, they can use different cipher suit or different certificate, and these to this they can use different certificate. So there will be some requirement, web server you are using legacy system and some system is not uh, compatible with the cipher suit or some other algorithm, then in that case, you know, you expose and client is asking, no, I will go for AES algorithm or something, then let them go. So you expose them HTTPS and then will expose another URL on HTTPS.
Sorry, Manish, for interruption. Just
Mhm.
something coming in the chat. If there is any difference in terms of what applies each deployment model, so if there is any differences in the application between RTF and Cloud Hub and other deployment model, if you can stress on the differences, that would be great as well. So if you didn't mention any differences, then the assumption is this applies to all the deployment models.
Yeah, I mean,
Is that
see,
correct?
this is something, as I said, right? So see, when I said deployment model, right? So either you can deploy in Cloud Hub or you can go for hybrid or RTF. So this secret manager is only applicable for API manager. API manager, you can deploy the proxy in hybrid environment or in the Cloud Hub. It doesn't matter, but as long as you are using API manager and API manager is compatible with hybrid and Cloud Hub, you can go for it. That's not a problem. So only thing you have to remember, this secret manager is only applicable for API manager. If API manager supports hybrid and Cloud Hub, you go for it. That's not a problem. Does it answer, Jimmy?
So if the API is not secured by runtime manager,
Mhm.
that means that we cannot we can't do the HTTPS encryption or TLS for this particular API. I'm sorry for interruption, but just to
Yeah,
clarify.
exactly. So see, this is quite this is not a policy. Okay, so this is just a I would say enabling the TLS context or TLS protocol. And even if you don't have a policy applied on runtime manager through API manager, still you can use this without uh, taking too much or worrying about something like API ID or API auto discovery. So you can use irrespective of what application you have.
Okay, so in this case, it doesn't require API manager. If I'm gonna use
No,
like just to configure the TLS context and then
no, it required API manager, but doesn't require policy need to be applied. Okay.
so does the customer need to have the entitlement of the API manager, because lots of customers might not have API manager entitlement on their
Exactly. So yeah, that's what. So you need to have API manager entitlement. That is why. So Secret Manager is free of cost. If you have API manager entitlement, you can use Secret Manager free of cost. You don't have to pay anything,
yeah.
but you need to have API manager for that.
Okay.
Does it answer your question,
Yeah.
Jimmy?
Yeah.
Mhm.
Thanks.
So again, I'll hand it over to uh, Mandy, and then I'll go for demo quickly.
Presenting Manish, just to
Mhm.
present the question, if possible.
Okay, that's good then. Mhm.
Yeah, yeah. Mandy, do you want to take over
Yeah.
from me?
So this will be our first trivia question, and please leave an answer in the chat after Jimmy types go now in the chat box. Any answers provided before that will not count, and you type either or B or C or D, not something like ABC. So if you could go to the next slide, finish like for the question. The question is, which microservices are responsible for reading the actual secret by Anypoint platform services, i.e. API manager?
So Mandy, someone has started giving answer in the chat because I'm not seeing the chat. I mean,
Yeah.
That's okay. You can skip over
yeah,
that.
but someone has started giving answer.
Yes, yes. I'm
Oh, great.
seeing the answers.
Mhm.
Okay. Yeah, I got it. We're gonna announce the winner at the end. So yeah, please go ahead in the next slide.
Yeah, thanks. Yeah, so I'll start with the demo quickly. I'll not take much time because mm, so I have two basic application. You can see because if you see, so mm, I have one application where I have exposed the HTTP URL, just a HTTP, not the HTTPS. This is the first application. You can see the name demo-http-meetup. It means this application is using HTTP protocol. And if you see, I'm just printing a uh, message. You can see this receive from HTTP means of deployed application. So it's just a simple application I have exported and I have deployed in a runtime manager. I'll show you. This is not something that I'm going to right click, extract it, you know, go to the folder and upload it. This is something that you guys are more expert than us. So yeah, you can. This is one application. I would like to explain quickly another application. Our agenda is just to explain how you can use HTTPS proxy using Secret Manager and API Manager. So if you see, this is something I have exposed on HTTPS protocol. If you see, mm, I have created a key store. I mean private certificate using key tool, and this is just a uh, just to enable the HTTPS protocol. So I have created a key store. If someone is interested to know the how to create key store, I can show you, but let me know. So this is something that I have created a key store. I have kept somewhere in a SRC main resource, and I have referenced it to HTTP listener. So when I am referencing TLS context, it means the HTTP become HTTPS. So you see this TLS context edit in line. I'm not explaining this. So there are two application. Let me log into the runtime manager quickly. Hmm. Okay, so you can see I have deployed two application called demo HTTP meetup and demo HTTPS meetup.com. Okay, so this is something. If you see the first application, see, so this is the first application response. This is nothing but a backend implementation, like server, backend server. We have exposed this backend server on HTTP protocol. So similarly, you can see this one. I have this is something coming from HTTPS deployed application. So these are the two backend application. You know. So these are the. So what I'm trying to show. I'm trying to show SSL offloading. What does it mean? SSL offloading means client will send the request on HTTPS protocol, and load balancer will redirect HTTPS to HTTP. It means in SSL offloading, I am going to use this URL as a backend. Okay, so because a client will hit on HTTPS, that is nothing but taken care by the API manager and secret manager, HTTPS one, and then once you try to hit HTTPS one, then this load balancer or the API manager will redirect to HTTP protocol. Okay, so basically I'll quickly show you. So go to the secret manager. So if you see the secret manager, as I said, it's a free entitlement. You need to have a API manager. Um, so this is something that I'm using this sandbox. So quickly I will show you. I already have created, but I can show you quickly. So you can you can give the secret group name. So what is secret group name? Group name, as I said, this is nothing but a folder name. Okay, so demo. This is nothing but a folder name, and this is something you have to check. So this check means if you are not checking, it means you can't see this folder available in API manager, because end of the day you are going to use this, the folder in API manager to reference the TLS context. So if you are not checking this one, it means this folder is not, or whatever, like TLS context, certificate, trustor will not be available on API manager. This is something much more important. This description is nothing but confusing. This is something might well check with MuleSoft why they have written like this, but this is something uh, I can show you in the real. Like if you didn't check this one, you will not able to do anything with API manager, and doesn't make sense. Okay, so I just created demo secret. Okay, now this is nothing but a folder. Inside this folder, you are going to do everything like key store. So I want to add key store. So what I will do, just go, demo key store, demo key store. So these are the format supported. You can see like PM JKS, and this I will go for JKS. Quickly, I will have a key store. So I will store. I will. You need to give the password to the key store. Now, if you see the alias, right? Alias is automatically coming. Okay. So in key store, if you have a multiple certificate, multiple private key, you can have a different, you can give the different alias name, and you can select whichever alias name. So I have only one alias name, so I have selected only one. Okay, so this is something, again the password it's asking 194. Then the override expiration date, this is nothing but just for alerting purpose. So guys, I mean, you will not find the real definition, but this is just for alerting purpose. So if you are using key store and the expiry of the certificate is going to expire in 2022, then you keep the date here. MuleSoft will give you the alert before 10 days or something, that your certificate is going to expire. But this is not in a scope, I mean, not enabled by MuleSoft now. The people are working in the background, so this is not enabled, but this is for alert only. Okay. So again, I have created key store. Similarly, you can create trust store. See, I'm not going to explain now. It's quite easy now. See, you can again uh, give whatever you have, something like that. See, if you want to store certificate, you can store the certificate. So certificate only support the PM extension. It doesn't support like CER and other extension. It only supports the PM certification. Okay. Then again, share secret, pin set. You have username, password, symmetric key. So this service is not enabled by MuleSoft. This is something only for the fancy UI. This is something not in action in real life, I would say. You can store, but this is something that you can't use. So even if you are using REST API, you will get only the metadata of this, not the actual secret. So this is just a fancy UI, just for your information. Again, TLS context, as I said, TLS context is nothing but a combination of key store and trust store. So you can give the TLS context name and target. So this is something much more important. So TLS context has two type of target. One is anypoint security and another is mule. So anypoint security means only for runtime fabric. If you are going to use secret manager for runtime fabric, you have to select target as anypoint security. If you are going to use secret manager for API manager, you have to go for mule. Okay. So this is again, these are all the CRL. Like if you have a multiple certificate and you want some certificate, you know already some certificate got compromised, then you can add as a revocation list in this. Okay. Okay, so quickly I will show you. This is something that I have created. Download, delete. I will delete this. Okay, no, okay. So this is something that I already have created just to show you guys. Demo secret group. If you go to the key store, I have, the same key store I have uploaded. This is something that I have created using key tool command or okay, and you can see, right? So this is something I have uploaded, this certificate, alias and expiry date. I have also created trust store. You can see the trust store. See, I have a demo trust store like truststore.jks. So I have created trust store also. And in TLS, I have created also TLS context. So this TLS context, I have created two type of TLS context. One for uh, SSL offloading and another for SSL tunneling. So in SSL offloading, it means you are hitting at HTTPS. It means you have to use the key store at HTTPS private key. So that is why I have kept this TLS context key store. Can you see this? This is nothing but a key store. Again, TLS context. This is trusted store. I have, so in this part I have stored the private key. In this part I have used the public key. This is just a simple one. So whatever the server you have, you just export the public key and import into the trusted part. Okay. This is something more about the secret manager. We'll see how everything is in action. So I'll go to the API manager. Okay. So this is something I have created. You just you can create the managing instance from the exchange. So, I already have created two type of asset in exchange, HTTP asset. This is something that it's coming now. And if you see for HTTP, if you see, right, so this is nothing but a backend implementation. As I said, right, this is something I'm going to show SSL offloading. It means client will hit on HTTPS and load balancer will call HTTP in the backend. Okay, so this is something that backend URL on HTTP. Okay, now if you see this, right, the advanced part, advanced option, see, this is something that inbound traffic. So inbound traffic for input. Now if you see this one, in inbound traffic, I am just using TLS context. TLS context is nothing but a private certificate. Key store I am using just to enable client on HTTPS, and I am giving this proxy name. So this will nothing but your proxy URL will have HTTPS protocol with this certificate. You got my point? So proxy, this is nothing but proxy URL. I will show you. Proxy URL will have HTTPS protocol using this certificate, and internally it will call this implementation. So this is nothing but a SSL offloading. A SSL offloading, client will hit on HTTPS and internally it call HTTP. Okay. So if you see, right, so this was my internal implementation on HTTP, correct? SSL offloading, as I said, right, if you see application name, demo HTTPS proxy HTTP. So this is something demo proxy HTTP, US East Cloud Hub dot, and this is the path. If you see, this one is the path given in the, I would say, in the implementation. So if I hit this one, you can see the response is received from HTTP deployed application. It means the client is hitting on HTTPS, but internally you are calling HTTP. So this is nothing but SSL offloading. I mean, load balancer is responsible to terminate this protocol of certificate encryption at load balancer level itself, and they are passing the normal protocol to the backend. So this is nothing but a SSL offloading. Similarly, I'll quickly show you this part. It's quite easy. Don't have to do anything. So what will happen on HTTPS SSL tunneling? So client will hit on HTTPS. Load balancer will also pass this protocol on HTTPS itself. I mean to the backend. So what will be the context here? So in inbound you will use key store, and while calling outbound you have to use trust store. So when I say trust store, public certificate of your backend implementation. So what is the backend implementation? This is the key store. So I can export the public certificate from here, and I can configure in the trust store. I'll show you quickly. See, our this is nothing but our backend implementation, HTTPS implementation, correct? This implementation will use this public certificate, trusted. How I will get the certificate? Whatever the implementation you are implementing in a studio, extract the public certificate from the key store, you know, and configure here. So this is something that I am referring from secret manager. So I can remove this at TLS. Demo node. I don't know, it's not visible. Something download. See, it's not visible, but trusted request TLS. Mhm. So this is something that you can refer this whole inbound and outbound certificate from the secret manager. Okay, now save. So this is again a proxy URL name. Okay, so for tunneling is nothing but you are calling inbound on HTTPS. So if you see, right, this is nothing but your proxy URL. This proxy URL uh, will use the HTTPS protocol, and it will call internally the backend implementation on HTTPS. This is nothing but a public key. So if you see this one, let me show you collection. So this was our backend for tunneling. Like this is using HTTPS protocol, and tunneling. This is nothing but our tunneling URL or tunneling proxy name. So this is nothing but a HTTPS, and this is something we are referencing from the TLS context of the secret manager. If I hit something, I can see. So this is, uh, this is something you can achieve through secret manager. So secret manager is all about storing certificate and referring to API manager. You don't have to do anything. Just create a certificate, store it in secret manager, and refer it. That's all. This is all I have now. I would like to ask people to have any question or something. I will be more happy. Uh, so Mandy, this is all from demo perspective. If you
Yes,
have some
and we
question.
have a lot of very good questions.
Mhm.
The first one I like to ask is, can you quickly demo how we can use passwords from the secret manager, or is that going to take a while?
No, so as I mentioned, right? So if you go to the secret manager, so you have to create one folder. So this is nothing but our secret group. If I go there, go to the share secret. So share secret is nothing but responsible for password and username. Okay, go. So password, process
Mm.
store. Okay. Now you have to select the type. Okay. So this has 3 to 4 types. So username, password, symmetric key, like for might be encryption key, you can say, a public key, and S3 credential and blob. So just I've selected this one, and password, username Manish, and password 1 2. 3. Okay, whatever. 1, 2, 3, 4. And you have to give, this is optional, you don't have to worry about. Okay, so this is something you can store username password. But as I said, this is not in action as of now by MuleSoft. This is something that there is no meaning to store username password in share secret. No one, you can't use anywhere in the platform service. So it's just a fancy UI. Even if you are calling REST call of this share secret or secret manager, you will not get the password in the response. So it's just a fancy UI for now, I would say.
Okay. The first I have is how much latency can be introduced when using Secrets Manager for storing credentials used in client applications, especially if not Cloud Hub based. If this is used for certificates as well, that is 2 extra calls within the application.
Yeah, so okay, so this is very good question, Mandy. So from latency perspective, I can't commit you the exact or can't tell you the exact timing, because this is something that you guys can test it and do it. But this is something, one important thing I would like to highlight. It's not the two call. The first time only API manager call. If, only the first time API manager call REST call to get the certificate. So if you download the proxy, so what I did, after deploying the proxy, I have downloaded the proxy here. You can see. So first time API manager call the secret manager REST call, take the certificate and keep, they used to keep in the src main/mute. Can you see this? Inbound and outbound key store.
Yes.
So whatever, only for the first time. If you are changing the certificate, then only the API manager will try to call second time. If you're not changing the certificate, it means you already certificate is present in your application, in proxy application. So not every time API manager will call REST call to share secret or secret manager. It's no. So you can download the proxy, you can see it's already there. Can you see this? Inbound
Yes.
and outbound,
Mhm.
it's already there. See? So you don't have to worry about the call and all. Okay. Only the first time it will take much latency, much time, much response time. But in second time you will get drastically decrease like anything. But if you're
Okay.
changing the certificate, you have to redeploy the application, because secret manager, API manager call REST call, and during the REST call, they will download the inbound key store trust store, and they will replace with the old one. So that is why you have to redeploy the application if you're changing the certificate.
Okay. And we'll do one more question before we move on to Brian and Connor's demo. So does this replace configuring the secrets inside mail projects?
No. So as I said, this is not applicable for any Cloud Hub application, any application apart from the API proxy. So it's not like that I am creating a normal application and I'm calling it outbound call and I can reference a share secret manager, in the application. No, this is something only for proxy, not for the Cloud Hub application or normal application. You can't
Okay.
reference even by calling REST call. You can't do anything. This is
Okay.
only for proxy.
Okay. Thank you, Manish, for
Yeah.
that really good demo.
So guys, I mean, like quickly, it might be something I would have shown, but you guys can reach out to me on LinkedIn or somewhere if you want to know deeper dive concept of
So,
anything. Yeah.
Manish, there are a couple of other questions. If you're staying around and we have time around the end, I'm not sure if you're gonna stay around. I know it's gonna be too late for you in Poland, but if you're around towards the end, then we have maybe a few other questions that we can ask you.
Yeah, no problem.
Thanks.
Mhm.
Do you want to switch over to Brian now, Mandy?
Yeah.
Okay, perfect. Brian, go ahead.
Yes, let me go ahead and share my screen. So hopefully that's popping up. So my name is Brian Sekevicus. I'm going to quickly go on video here to say hi to everybody. I am the MuleSoft practice manager here at BitCompass, and I'm based out of Denver, Colorado, otherwise known as the Mile High City. I guess I could say the 1,600 meter city for those of us who are in Canada, but that doesn't quite sound as impressive. I've been in the integration space forever, over 15 years. Most of my experience is with on-premise solutions, mostly Oracle. If you want, I can even go back to the BEA days, which gave us a WebLogic application server. I've been on the MuleSoft side for about 2.5 years now. So what I'm here to do, I'm going to be joined shortly by one of my team members, Connor and Fitzgerald. We're going to talk about Runtime Fabric security, and we're going to specifically cover 4 different areas. I'm going to start with what you need to do with your network security. Then we're going to focus on securing your APIs, securing your credentials, which is a little bit different than you may be used to in Cloud Hub. And finally, Connor's going to talk about securing data with the tokenization service. So I'm going to go off of video for now. I'm going to go ahead and start with the network configuration for RTF security. So the diagram I have here on this slide is showing what is considered the best practice for Runtime Fabric. Of course, you have your controller nodes, and you have your worker nodes here along the bottom. You have an external TCP load balancer, and this is what is going to be the interface between an incoming request and your Runtime Fabric. Your agents, of course, are deployed to your controller nodes. So basically what happens is the TCP load balancer receives the request, forwards the request to an available internal load balancer. That internal load balancer decrypts the request and goes ahead and forwards it to one of the replicas of your applications that are running on your worker nodes. Your worker node does its thing, returns back to your internal load balancer, and returns back to TCP load balancer, which then, of course, returns a response back to the consuming client. It's important to note here that all nodes that I'm showing in this diagram are on the same subnet. This is the current recommended configuration that allows you to keep your network a little bit more simple, and it also reduces latency. Now, there are a few other considerations, of course. What are some of the best practices around configuring your network? I mean, these are pretty obvious. Only open the IP addresses that you have to actually expose to the outside world. An external load balancer is considered the best practice because then that ensures that ingress communication, which is of course part of Runtime Fabric, is limited to the trusted source here. Only open up the ports that are required to be open, 443 for SSL, 80 for HTTPS. It is possible to deploy using a public and private subnet model. Just be aware, you're going to have to deal with some latency across your subnets. So again, MuleSoft's best practice, one subnet. Of course, separate your worker nodes from your controller nodes. They recommend 3, so if one goes down, you still have 2 for fault tolerance. And again, make sure you have at least 2 replicas of your application somewhere on your worker nodes. So again, network security, some of this is common sense, but just be aware that if you don't have your network secured correctly, everything else is pretty much going to be insecure. So that's all I want to talk about in terms of network security. I don't really have a demo for it. I want to focus a little bit more on Runtime Fabric API security, and then we'll go into actually securing your credentials. The best practice for any type of API management is to adopt the principles of layered security. The idea there is you have multiple components protecting multiple levels. This allows you to have a backup. So if one layer has a flaw or a gap, there's a backup that should pick up that flaw or gap. Usually this is considered superior to just having a single layer of defense. Of course, with anything, there's drawbacks to it. Depending on what components you're using, this can get costly. If you're using 3 or 4 different types of components, you're going to need 3 or 4. You're going to need different skill sets within your organization to maintain these components. And of course, the more layers you have, you're going to add some overhead to your HTTP calls, so that can impact your performance a little bit negatively. So just be aware of that. So let's talk about how we implement these layers. I'm going to go from first, second, and third layer. I'm going to start with the API gateway. I think most people here are familiar with the API gateway. This protects against brute force attacks, simple attacks. You can protect against SQL injection attacks also if you want to. There's a few different types of policies you can apply, which are all listed here. And in one of the demos, I will show you how this is actually going to work with the second layer, which is the WAF or RASP layer. WAF, of course, is Web Application Firewall. RASP is Runtime Application Self-Protection. These protect against what the organization OWASP refers to as the top 10 attacks on your network. And I've put a link in these slides to those top 10 attacks. When you combine this layer with the API gateway, you can defend against multiple threats: SQL injection, denial of service, cross-site scripting, etc. View the WAF policies as global policies, and then you can have much more fine-grained policies on your individual APIs as necessary. So far, the first two layers are going to be really good at protecting against certain external attacks, brute force attacks, the top 10 attacks, etc. But what happens if the credentials you're given are valid, but they're really held by somebody who wants to do some malicious things to your network? That's where the third layer comes in. And this is called the machine language or AI security engine. This is implementing what is known as zero trust. So even though I'm saying I'm Brian Stekevicius and I presented my credentials, the idea here is, yeah, you say who you are, and yeah, I believe you, but not really. So basically what I'm going to be doing here is, okay, Brian, what are you actually going to be doing in my network? And this is where the machine learning or the AI comes into play. If I'm doing something that's really not normal for me, in other words, I'm not just querying one employee, I'm querying all the employees, I'm pulling out everybody's social security number or pulling out everybody's ID, credit cards, whatever, the security engine is going to flag that and hopefully prevent me from doing it in the first place. So that's where you can protect yourself against, like we said, stolen tokens and credentials. They're all valid, just that somebody stole them and you don't know somebody stole them yet. So-called insider threats, and of course, again, abnormal operations for people who have authenticated access. As people leave enterprises, sometimes it's the credentials aren't disabled. This is a great way to say, oh, wait a second, that person left. They're doing a lot of weird things here. We're not going to allow that, which again, the first two layers won't capture. So we talked about the three layers. How do you apply this to Runtime Fabric? So there's going to be two parts to it. First of all, the API manager, which I'm assuming we're all familiar with. You can go ahead and apply policies directly to your MuleSoft applications, directly to your APIs. Then there's Anypoint security, which is going to apply the edge security policies. I could do whitelists, I could do HTTP limits, I could apply a WAF here. Those are going to be a little bit more global, and they're going to apply to all the applications within your Runtime Fabric. However, this does not solve the third layer, which I talked about, MLAI. However, if you do have a third-party solution that's deployed, you can create a custom policy, and that will go ahead and enable that layer of security. So it is possible to implement all three out of the box. Anypoint platform with Anypoint security on Runtime Fabric can handle two of these: edge security and also the regular API manager. The MLAI is not supported, but it doesn't come with MuleSoft, but there are third-party applications. Just create a custom policy and you can apply that. And we will demonstrate how these work with Runtime Fabric. My next topic I'm going to talk about is encrypting properties at rest. Sure, a lot of you are familiar with the problem is that your enterprise information systems need to have credentials. Usually when you're dealing with an integration solution, we create a service account for that, so that when you're logging, when you're auditing, you could see, okay, it was a service account. It was the automated integration solution that came in and queried my Salesforce application. However, you may have policies where these credentials need to be updated every 90 days or something like that. You may also have to deal with securing some other sensitive information like URLs, IP addresses, usernames, whatever. Obviously, the absolute bad practice is to put these credentials out in plain text. You'll fail every security audit, and we'll just not even talk more about that. Don't do that. So how do you do this with Runtime Fabric? I'm sure many of you are familiar with the concept of secure configuration properties within MuleSoft. You download secure properties tool.jar. You also have to get the Mule secure configuration property extension, which I'm showing here on my screen. Just grab that from Exchange. Of course, you can encrypt individual properties, all the properties, or if you want to encrypt the whole file, you can do that too. You can do it on YAML or properties files. And when you're a developer and accessing these, and I'll show you this, you preface your properties with secure and a double colon. MuleSoft 3 used to support the premium security connector, which you can go ahead and download from this site. The solution isn't in official MuleSoft 4.3 documentation. You can only use this with properties files, not YAML files, because it messes up the indentation. I'm not going to cover this solution. I know DR Zone does have a nice posting on that. If you're interested in figuring out how that works, you can go, or using that solution, you can go ahead and refer to it's on the DR Zone site. So now we've secured the configuration properties. The challenge is, what do we do with the decryption key? And that's where we're going to introduce the concept of safely hidden application properties. I want to emphasize this isn't the same as Cloud Hub safely hidden properties, and I will show you that in a demo. As you know, with Cloud Hub, you have the ability to safely hide your properties. You specify which properties you want to hide in your mule-artifact JSON file. Usually a best practice, or a better practice than even just entering them in Cloud Hub, is to inject them with your CI/CD, with your continuous deployment pipeline. I worked for a customer that used Azure DevOps, and that was our standards. We used safely hidden properties, but we injected them with the pipeline. So we never actually went into Anypoint Runtime Manager and entered the properties manually. And the nice thing about that is we had a unified tool, because other applications use Azure, the CI/CD pipelines. So it wasn't just limited to MuleSoft. So it provided one tool and a common way for us to go ahead and deal with safely hidden properties. Again, that's Cloud Hub. Runtime Fabric, it does not work that way. However, what you can do is go to the command line in your Ops Center and use the RTFCTL tool. And I've shown you the command right here. You basically apply a secure property, key value, and the environment, of course, is going to refer to either your sandbox environment or your QA environment or your production environment. Any application deployed to this environment will be able to see this secure property. Note that you can still actually view the properties. In my example here, here's how you do it. I'm providing the environment ID. You get back key, and you'll see the value in plain text. So it's kind of sort of safely hidden, but if you have super user access, you could still get at the properties, which, you know, when you're in Cloud Hub, once you enter a safely hidden property, you can't access it again. And certainly with some of the DevOps tools, when you inject the property, again, you type it in once, you hit the secure key, and you can't get it again. The only thing you can do is delete and re-enable it. So that's what you do for safely hidden application properties. So what I'm going to do right now is I'm going to demonstrate these concepts. You're going to see me doing some local connection testing. I'm going to point out one of the challenges that you have with local connection testing. I'm going to show you some safely hidden properties on Runtime Fabric, and I'm going to show you how some of these Edge and API Manager policies work. I'm not going to bore you with deploying to our Runtime Fabric. It does take a few minutes, and our time is better served by actually seeing a demo. So what I'm going to do is get out of this before I get into trivia questions, and I'm going to open up my application, my Studio application. So in this particular instance, what I'm going to do is I'm using my safe and secure properties. I'm using my secure properties here, but right now my username is in plain text. And somebody said, no, we don't want to do plain text anymore. We only want to use secure properties. So over here, I have my secure properties YAML and my properties YAML. So what I'm going to do is I'm going to comment out my plain text property, ultimately remove it. Then what I'm going to do is I'm going to go over to my favorite command line tool, which in this case is the command prompt. Here's the command line tool. I'm going to use the blowfish encryption. There's what my key is, and then I'm going to go ahead and turn Big Compass into this. So what I would do then here is just copy it. Whoops. Let's copy this. And then, of course, here, paste it in. Should be good to go. Let me go ahead and save my secure properties here. I'm going to go ahead and save this property. I'm going to go into my globals. I'm going to edit. I'm just going to simply say secure. And then go ahead and test the connection. And I was able to connect to my database. So one thing I will point out is the challenge with using test connection from within the UI is where's it going to get the decryption key from? So temporarily, I created a decryption key as a global property in my application. Obviously, I want to make sure I delete this. Again, for local testing, that's fine. Obviously, I could also just go ahead and debug and pass this in as a command line parameter. So that's a simple demo of how you go ahead and you encrypt your properties. The downside of doing this way, in my opinion, is that this is going to be in your repo. Now, yes, you have to get a hold of the key, but once you get a hold of the key, you could decrypt all these properties. So I'd rather not put these properties in my repo. That's where I'd rather use safely hidden properties in Cloud Hub. So let's go ahead and take a look to see what this looks like in Runtime Fabric. So first thing I want to do here is we happen to have on our Runtime Fabric. Let me go get my browser back up. Here we go. Okay, what I have here is I have a Pokemon application. For those of you who attend the Denver MuleSoft meetups at all, you know we like to use Pokemon application. So we have this deployed here into Runtime Fabric. And if I look at my properties, you can see here, I don't have my decryption key. So how am I actually going to get at it? And the answer to that is I'm going to go into the DevOps Center. I have to get my password. 1 second, please. I would go into my server. I would go into my controller node server, SSH login as root. Go find where I actually installed RTF control. In this case, I'm just going to go ahead and get secure properties. I've already getting my environment ID, so I'm going to get that. Like I said, there's my key and there's my value. So I do have that decryption key is accessible to all the applications that I put into my sandbox environment on my Runtime Fabric instance. So that is how I have safely hidden that property from within the application. So let's go ahead and see if I could actually get the application to work. So I'm going to go ahead and do is I'm going to go ahead and first see if I can hit, we have a hello world application deployed, because who wouldn't have a hello world application deployed? And I've got a problem here. I can't connect to my application, to any application on Runtime Fabric right now. I don't know what that problem is. The answer is I've applied an edge policy. So if I go to security, I see right here is I have a security policy RTF allow. If I go back to my Runtime Fabric, let me go to actually Runtime Manager. I'm going to open up this in a new tab. If I go to Runtime Fabrics, if I go to my Runtime Fabric instance, I can see under inbound traffic, here's where I'm applying my edge policies. And you can see right now I have RTF allow deployed. If I go back to my RTF allow, which is my IP allow list, you can see here we have the CEDAR codes of the IPs that we are allowing to hit. My IP address is not in one of those IP allow my allow list, so therefore I can't go and hit it. So to keep things simple, I'm just going to go ahead and change this to no policy, because Connor's also going to be using some of these policies. So I'll just keep it simple here. Then I'm going to do a save and deploy. Fortunately, this does happen pretty quickly. His famous last words, as he says, is that play happens pretty quickly. And now, of course, applying. OK, there, we're done. So I'm going to need to wait probably another minute or so before I can go ahead and actually hit it. So it's still applying the policy there. So I'll give it another minute. One thing I'm going to show you while I'm waiting for this to come up is if I go back to my applications and I look for Pokemon, I have a Pokemon application deployed to Cloud Hub. And again, here the settings. If I go look at my properties, here's my safely hidden decryption key. I can't get at this value. I can only delete it and re-enter it if I had to. So if I go back to my Hello World application, hopefully I'll be able to hit it now. Nope, still doesn't want to react to me. Of course not, because it's a demo. There we go. Now I'm able to connect. So it's allowed my IP address through. So now I'm going to go ahead and hit the Pokemon application that I've already deployed in the Runtime Fabric to go see if this is to go get the information I need. And I'm going to send a request. And here we are. We have the information. What I want to show you quickly is I have the ability to go into API Manager. And then find my Pokemon. I go into my policies. You can see here I have a basic authentication set up. I'll enable that. Go back to Postman. And eventually this will reject me. So basically the idea here is once this is actually enabled, yes, it is enabled. So it just takes a little time. You don't want to enable. Should miss a step. Nope, it's there. Eventually, I would see that I'm getting that this policy will apply to just this particular application. So what I've shown you is I've shown that I can apply these. These are the API Manager API level policies, which are against my particular application. I also showed you back in. Let's go back to Runtime. Let's go back to. I am in Runtime Manager. Let's go back to my Runtime Fabric. And this is where I apply my edge policies to Runtime Fabric. So is it actually going to apply now? Nope. Okay, I missed a step somewhere, but this should be rejected on the Pokemon application. I'm going to reapply this because I know Connor is going to be using it. So hopefully this demonstration showed a bit about how you deal with securing your credentials and also how you apply policies, both edge level policies and also API specific policies to your applications deployed to Runtime Fabric. So I believe with that, it is time for a trivia question. So Mandy, go ahead.
Thank you, Brian. So the trivia, the rules are the same as the first one. Please don't put multiple answers, and your answer will only count after Jimmy types "go now" in the chat box, and you type either A or B or C or D. So for the question, what is the most secure way to quote unquote hide sensitive configuration properties? Is it A, secure configuration properties, B, Runtime Fabric safely hidden properties, C, Cloud Hub safely hidden properties, or D, continuous development and deployment injected properties? Okay. So thank you for all your answers. And now we'll move on to the last section of our presentation given by Connor.
everyone. I'm going to share my screen. All right, so again, I'm Connor Fitzgerald. I'm a senior consultant with Big Compass, and today I'm going to talk about RTF's tokenization service. So what exactly is tokenization? At its core, it's quite similar to hashing or encryption, where you're trying to obfuscate sensitive data coming in before you're passing it down to, or passing it on to downstream systems or storing it at rest. One of the main benefits of tokenization is that it is format preserving. So if you have something like a sensitive credit card number coming in, the tokenization service can be invoked and you'll receive a token back, which looks exactly like the incoming credit card number, but is now obfuscated, and it provides no extrinsic or exploitable value. And you can safely pass that on to downstream systems. To get started with tokenization, you'll first define your token formats, and then you're going to have to deploy the tokenization service to your RTF instance. Depending on how many tokens or token formats you have defined, will determine or dictate that deployment time, as well as the memory and CPU requirements of the token. Another benefit of tokenization is that it's reversible while simultaneously vaultless. There's two benefits to it being vaultless. One is that as you provision more and more tokens, your memory footprint is not going to scale with that. And the second being that if a bad actor does gain access to your RTF instance and tokenization service, there's not going to be something like a lookup table or anything that they can find where these original credit card numbers are in plain text. It's highly scalable, and whether you are scaling your tokenization vertically or horizontally, you're going to see linear performance increases. It's very flexible and customizable to support your downstream systems. And out of the box, MuleSoft provides several formats supported, those being things like credit card numbers, social security numbers, and email addresses. Additionally, you can further customize those built-in formats. So let's say you want it to mask certain values, you can do so. Or for, let's say, a social security number, if you want to preserve the last 4 digits of the social security number, you can do that while tokenizing the rest of it. So there's 2 different ways you can implement the tokenization service. One is you can expose it as a service directly to your RTF applications, or you can apply tokenization policies through API Manager. And those policies will replace the sensitive information that's within the payload. It's important to note that only information within the payload can be tokenized. You can't apply this to things like headers or query parameters. The policy itself is highly configurable. So within API Manager, when you're setting up your tokenization policy, you're going to specify a selector expression. So let's say your credit card number or sensitive data is nested deep within the payload. Well, that selector expression is just a data weave expression that's going to tell the policy where to extract the information and what to tokenize. You can specify whether tokenization should occur on the incoming request or the outgoing response of the proxy. And then in terms of formats, you can specify one or several. So let's say you have a request coming in that contains email addresses, credit card numbers, and social security numbers. Well, you can specify that format and the selector expression for each of those individually. To kind of queue up my demo and paint a picture of a good use case is, let's say your goal is to maintain a ledger, and in that ledger you want to have your accounts and the associated charges with that account. But your primary key for those accounts is credit card numbers, and you don't really want to have those credit card numbers stored in your ledger if you want to expose this to downstream systems and downstream lines of business. So let's say we have this order system, and coming out of that order system is credit card numbers and new charges associated with that credit card number. So as soon as the credit card number hits your tokenization proxy, it's going to extract the credit card number from the request and immediately pass it to the tokenization service. The tokenization service is going to return a now non-sensitive and non-vulnerable token of that credit card, but it's going to be in the exact same format as your incoming credit card number. And then you have this credit tracking app, which is updating and inserting this ledger so that all the charges associated with that credit card number are maintained in here. And from there, you can expose that to, again, downstream systems, or let's say your finance team wants to draw insights from these charges, but you don't want them dealing with actual credit card numbers. well, now they can safely be given access to this ledger. Another entity you might want to have access to this ledger is your payment processor. So whether it's on a fixed frequency or at a certain dollar amount, let's say your payment processor will pull from this ledger and it wants to actually execute those charges. So it's going to send it to your detokenization proxy. And one of the main differences between these two proxies, other than one being tokenization and the other being detokenization, is that this tokenization policy, again, is tokenizing the incoming request, whereas this one is going to tokenize sensitive data on the outgoing response. So you have the token coming in, and then you may have another application that it's going to be either doing, let's say, an audit report or alerts on these charges that are about to occur. Well, it can do so safely with the token, and then on the outgoing request or on the outgoing response, it will then be detokenized so your payment processor can actually execute those charges. See, it's a demo. For what we're going to see again is these tokenization and detokenization policies in action, and then a quick demo of some added security that the WAF will provide. Okay. So again, this is supposed to be our orders basically. So we have our plain text credit card number and a new charge. So if we send this charge to the tokenization proxy, it's going to tokenize the incoming credit card number and pass it to that app, which updates the ledger. So if you look at the ledger now, we saw that this is again the token of the card number. It is non-sensitive and intrinsically not vulnerable. And we see originally we had 600, now we're up to 650 on the charges. And let's say 650 is the cap. Any account that gets to 650, we want to charge. So we can have our now payment processor is going to extract that token from the ledger, and it needs to determine exactly what the original credit card number was to make the charge. And so here we can reverse the token and get the original sensitive credit card number. And that's it for my demo. I'll pass it back to you, Mandy, for the trivia question. Oh, I forgot about the firewall part. So here's our web application firewall where it's detecting SQL injection attacks. So if we send anything with a SQL script in the query parameters, it's going to automatically reject that request. And then same with cross-site scripting attacks. Again, our web application firewall is refusing this request before it is past the load balancer. And now I'll turn it back over to you, Mandy.
Thank you, Connor. If you could keep showing the presentation so I can read the next trivia question.
I can share. Okay, go ahead.
Okay, so this is the last trivia question, and we're asking you which one of the following is true. Please wait until I read all before you put your answer in the chat box, and of course only after Jimmy says go now. So the choices to select from are A, the tokenization is reversible but requires a lookup value. B, memory requirements increase with number of tokens provisioned. C, runtime fabric installations include the tokenization service by default. And D, portions of the original sensitive data can be preserved. Okay, thank you for all your answers, everybody.
I think I can share my screen. Connor, thank you very much.
Pass it back to you.
Okay, thank you. All right, it's time now for Q&A, guys. Mandy, do you wanna let me share again?
There were a lot of good detailed questions while Brian and Connor were doing their demos. So We have a question from Sandeep saying that the problem with properties files is that they are part of the build and changes become difficult. And he's saying RTF CTL actually not secure because anybody can sneak in a one-liner code and expose the property value. And when he says anyone, he means any. So, Brian, can you elaborate on how secure is it to use RTF CTL?
So I mean, Sandeep is correct in that RTF-CTL doesn't necessarily secure it. You're just hiding the key, and you need to have sudo access to hide the key. Yes, if you are using decrypt key and somebody wants to do a log of the payload, yes, you're right. And then at that point, that's where that's why you have code reviews to make sure your developers are not doing stuff they're not supposed to do. That is definitely correct. You never log keys because you're right. You can get at it. So RTF-CTL does not secure. That is correct. All it does is it really hides it. So yes, obviously part of the security is you're only as secure as your weakest link, when in this case would be the developers. The properties, the common the common use of properties files is that you have different properties for different environments. So that's a standard practice, and that you'll have your dev, your QA, your sandbox, and your production values, which are then pulled in during deployment. So that's where you use the properties files. Hopefully I answered the question there.
Okay, thank you, Brian. And he's also asking, is the decryption key just masked or is it also encrypted?
It's so with RTF-CTL, it's going to be encrypted. I just happen to show you that you can get at the key itself. I didn't show I think I showed the commands in the presentation. Yeah, I think slide. Actually, no, it doesn't. It just hides. I'm sorry. No, it does not encrypt it does not encrypt it. It just hides it. It's
Okay.
basically what it's doing there. So again, I showed that the application was deployed to RTF, but I wasn't showing that particular key anywhere. But it hides it. It doesn't necessarily encrypt the key.
Okay. And Sandeep is saying that prod values are usually not available until late in the game. So we need to externalize the properties. And how do you recommend the best way to go about this?
It also happens to be the answer to the trivia question. The best way, in my opinion, is to have basically leverage your continuous deployment scripts. Like I know Azure DevOps, they have the concept of secure files, and you have somebody enter those properties into Azure DevOps, and then they literally hit like a little lock, and then that's it. You can't get at them. So developers should never see those properties, quite frankly. That's where using a common DevOps tool is the best way to do it. You can also, of course, just enter, and when you deploy into production, you'll have to, of course, you can always just enter them in Cloud Hub itself, as long as they're safely hidden. And that, of course, you have to specify within your mule-artifact.json file.
Okay, that is very insightful, Brian. Thank you. Now, I'd like to. Sandeep is saying I am specifically talking from Runtime Fabric.
So Runtime Fabric, the only way to hide properties is the way I showed you. You have to use RTF-CTL. So somebody's going to have to get into your going to have to go into the Op Center part of Runtime Fabric and basically hide the properties the way using the command that I showed in my presentation. I showed you the way you could see them, but you can hide them, and then you don't even see the fact that I'm using those properties when you look at the settings for the application in Runtime Fabric. You don't enter them into your mule-artifact.json file. Basically, you just say, okay, these are the properties I'm going to hide. I don't put them in my properties file. I access them in my code, but I don't put them in any of the properties file. So you basically have to use RTFCTL. It's the only way to do it in Runtime Fabric.
Okay. Sandeep is saying his EIS is going to give him a hard time for that.
What's that?
But his enterprise information security team. But if it's the only way, then
unfortunately, if you really want to hide the property, it's the only way to do it in Runtime Fabric. I'm sure there's a way in a deployment script that you could issue that command, RTFCTL, to do it into your, as long as you specify the environment ID. I'm sure there's a way to do it from within a deployment script. I mean, unfortunately, it is what it is. I don't know if I certainly have contacts over on the product management side to say, is this, this is the way to do it. Is there any other better way to do it? Like what you can do in Cloud Hub. So sorry. Don't shoot the messenger.
Well, yeah, well, that's really good to know, Brian. Thank you. And that was a really good demo for us to see exactly the command that is very helpful for developers, and it'll serve us well going forward. So we do have a little bit of time left, and I do want to circle back to some of the questions that the audience asked earlier. So, Manish, someone wanted to confirm if they heard you right, that the username and password cannot be retrieved through the API because the API can only provide metadata info about the secret and not the value.
Yeah, that's correct, Mandy. Yeah.
Okay, good. And there was a question about confirming the difference between the Anypoint security option versus the meal option in the TLS context. And I believe you said the Anypoint security option was for Runtime Fabric.
Yeah, that's correct. And Mule for API Manager proxy. Yeah.
Okay. And do we have key store JKS files in the application build?
Not really, because JKS, so see, like if you create a proxy, right? So there are two applications. One is your backend application and another is proxy deployed application. So in proxy deployed application, you will have your JKS. That is something secret manager or API manager internally call REST call to secret manager, take the file from secret manager and put it into src/main/mule folder, not the resource folder. So from the proxy perspective, my answer is yes, but from the application perspective, no. In application, you have to keep yourself the JKS and whatever you want, like JKS and trust or whatever. So yeah, so from proxy perspective, API manager responsibility to call a REST call to secret manager and take the JKS and put it into src/main/mule, and yeah, so this is something internally they do, but not in the application. So application is nothing but your right, your scope. As I said, secret manager is not uh, used for application. It's only for a proxy.
Okay, so this leads into the next question. I'm guessing the answer is no. Can we read the password that was saved in shared secret from a Mule application?
No.
Yeah. Okay. And there's a question about in the SSL offloading example, if you hit using HTTP instead of HTTPS, what would happen? Will it not work? It still works. What's the benefit here instead of
No.
using certificates?
Yeah, so it will not work, right? So if you are hitting on HTTP, it will not work because you have configured key store. You have deployed your proxy on HTTPS, means you have configured your TLS context with key store, private key. Okay, so you have to pass the certificate, otherwise it will not work. So HTTPS deployed proxy you can't hit with HTTP because this is something that a separate application API manager in the background uh, uh, have deployed or had deployed in Cloud Hub. So it will not work in short. So
Okay.
HTTPS means HTTPS.
Okay. Thank you for clarifying. There's a question about, can Secret Manager be used for last mile security in Runtime Fabric?
Can you come again, Mandy?
Can Secret Manager be used for last mile security in Runtime Fabric?
Brian, any idea?
No, it sounds to me like the security manager, the secrets manager. I'm sorry. You're dealing with putting in your SSL security. That's where you're dealing with your certs for TLS communications. I think I'm assuming last mile security. I mean, you have the edge policies, you have your API manager policy. You have, I'm not sure past that, like if you're talking about like encrypting fields. I mean, that's where the tokenization service can come into play to really, if that's what you mean by last mile security, the tokenization service would be a way to do it also. I mean, that way, as Connor demonstrated, you don't, like the credit card example he was given is that that's tokenized. So you, as you're working with within your application, you're not even seeing a credit card you got before. So I think that's what that means. It's a guess.
Okay. And we have our last question today, which is from Postman. Were you sending the certificate?
That's a question from Nish. Yeah.
Yeah. So no, we are not sending the certificate by default. If you go for trusted certificate by default, it's there. But this is something in the Postman. I had turned off the certificate validation, and this is something that API manager will take care of a certificate part. So we are telling API manager to use the certificate. We are not passing any certificate from the Postman. We are asking API manager to take the certificate from the TLS context of the secret manager. So
Okay.
in short, we are not passing the certificate, but we are telling API manager to take the certificate using REST call from the secret manager internally. So certificate is there itself.
Okay.
Mm-hmm.
Hey, thank you, Brian, Connor, and Manish, for those very insightful demos and all these interesting questions. The audience. So I'll pass it over to Jimmy now to announce the trivia winners.
I guess this is the moment everybody is waiting for, the trivia winners. So the first question was, which microservices is responsible for reading actual secret vault by Anypoint platform services? And the right answer is B. And the winner for this question is Mohammed Kajuriwala.
Wow.
Congratulations, Mohammed.
Congratulations.
Next question. What is the most secure way to hide sensitive configuration properties? The right answer is D, continuous development, injected properties. And the winner is Tuhinava Das. Congratulations, Tuhinava.
Congratulations.
The third question is which of the following is true? The right answer is D. Portions of original sensitive data can be preserved. And the winner is Mike Guthria. Congratulations, Mike. So what's going to happen next is I will submit the winners, the names to the MuleSoft meetup teams, and the meetup team, somebody from the meetup team will approach you and send you the free training, the vouchers for the free training. Congratulations to the winners, and yeah, thank you. I guess the last thing in our meetup today is to come back to Mandy for customer feedback. You started, Mandy, by having some point of view in the beginning. Would like to see how do you see the picture after this great presentation by Manish, Brian, and Connor?
Yes, so it was definitely everything I asked and more. And I thought the presentations complemented the demos so well. And on top of that, the audience's insightful questions helped solidify understanding of the concepts and techniques to secure APIs presented today. So thank you so much, all of you guys. Definitely answered all my questions, and I learned a lot and learned about the best practices, about practicing security in Runtime Fabric, and it's definitely something we'll take going forward, and we've learned so much. So thank you.
Right. I'd like to thank everybody. Thank you, Manish, Brian, and Connor. Manish, I know it's very late, so we really appreciate having you that late in the day. Thank you for the audience today. We hope to see you next time. Thank you, everyone, and have a great rest of your day. We'll see you next time. Bye.
Thank you.